All right, so we are going to be finding the derivative of an inverse trig function today. That's what we're going to focus on. And this video is going to be showing you kind of like the long way to do it. Your yellow sheet has some shortcuts, but what I've found is that the shortcuts are kind of complicated to remember, and so teaching you the long way might bail you out on a test if you have forgotten the shortcut. So we're just going to go through some examples so that you can see how it works. So we're going to start with y equals sine inverse of 2x. And since we don't know how to deal with finding a derivative of sine inverse, but we do know how to deal with the derivative of sine, I'm going to go ahead and I'm going to undo the sine inverse by doing the sine on each side. And then that's going to allow me to be able to do this problem using implicit differentiation, which is something that I'm fairly comfortable with. So now I've got sine y, which I know how to work with, and then 2x, which I also can work with. And so I'll do my implicit differentiation. So the derivative of sine y is cos y dy dx. The derivative of 2x is 2. So that means that dy dx equals 2 over cos y. So I have found the derivative of the inverse function, but my derivative is in terms of y, and I would rather have it be in terms of x. They're always going to want it in terms of x. So what I'm going to do is I'm going to go back to this part right here, and I'm going to set up a triangle, because SOHCAHTOA tells me that trig ratios are actually, they're representing, it's trig of an angle represents the ratios of two side lengths of a right triangle, right? So I'm going to go ahead and set that up. And sine, so I'm thinking the so part of SOHCAHTOA. So sine of the angle is opposite over hypotenuse. So this is the opposite side. The hypotenuse would be 1, because if I had 2x and I wanted to write it as a fraction, that would be 2x over 1. And so what I need to do now is I need to figure out what cos y is. So it's saying use the same triangle, and to find cos y, I would need adjacent over hypotenuse. And I do not currently have the adjacent side, and so I'm going to go ahead and label this as A. So I'm going to use the Pythagorean theorem to find my adjacent side. So adjacent side plus squared plus 2x squared equals 1 squared. And so a squared is 1 minus 4x squared. I went ahead and I just squared that. And then a equals the square root of 1 minus 4x squared. Okay, so now I can go ahead and say that cos y is the square root of 1 minus 4x squared divided by 1. And I don't really need that 1 in there. So now I can go ahead and do that substitution. And so my derivative is 2 over the square root of 1 minus 4x squared. And I'm finished. All right, here's my next example. I'm going to say y equals tan inverse of 3x. So again, I'm going to rewrite the problem. I'm going to undo the tan inverse because I would be more comfortable finding the derivative using implicit differentiation. So the derivative of tan is secant squared. So secant squared y dy dx equals the derivative of 3x is just 3. So dy dx equals 3 divided by secant squared y. And so now I have found the derivative, but it's in terms of y. So I'm going to go back to this information right here, and I'm going to draw a triangle for it. So tangent of an angle is opposite over adjacent, so that's going to be 3x over 1. And secant is the flipped version of cos. So since cos is adjacent over hypotenuse, secant would be hypotenuse over adjacent. I'm going to need that hypotenuse. So I'm going to say 1 squared plus 3x squared equals h squared. And so I've got 1 plus 9x squared equals h squared. And so h is the square root of 1 plus 9x squared. And so I'm going to say secant y is hypotenuse over adjacent. And so now I can go ahead and trade this out for secant, and I do have secant squared. So this is 3 over the square root of 1 plus 9x squared squared. And so the square root and the squared cancel, and my derivative is just 3 over 1 plus 9x squared. Okay, let's try another one. We're going to say y equals cos inverse of the square root of x. So again, I'm just going to get rid of that cos inverse so that I can use implicit differentiation. And so the derivative of cos is negative sine dy dx. This I'm going to go ahead and think of as cos to the 1/2. Sorry, not cos to the 1/2, x to the 1/2. So that's 1/2 x to the negative 1/2. And so I have dy dx equals, let me go ahead and write this, 1/2 x to the negative 1/2 divided by negative sine y. And then I'll go ahead and kind of clean that up a little bit. So I know I've got this fraction 1 over 2. I know that the 2 should actually be on the bottom. I'm going to go ahead and put the 1 on top. The 2 should be on the bottom. That's an x to a negative exponent. That should be on the bottom. So 2 square root x. And then we do have the negative. I'll go ahead and move that to the front. And then we have the sine y. Okay. So now I can go ahead and take this information and draw my triangle. So there's my angle. Cos is adjacent over hypotenuse, so root x over 1. Sine y is opposite over hypotenuse, so I do need the opposite side. You can use O as a variable if you want, but that could be kind of confusing if you look back at your notes later and you think it's a 0. So I'm going to go ahead and just call it A again, or B. I'll use B for the A, B, and C. So I'm going to say this is square root x squared plus b squared equals 1 squared. And so x plus b squared equals 1. B squared is 1 minus x. And so b equals the square root of 1 minus x. Okay, so that means that sine y equals opposite over hypotenuse, so square root of 1 minus x divided by 1. And I'll go ahead and make that substitution. Now, most people would probably not just leave this outside. And if you guys do recall, if you have the same exponent, you can multiply the insides together. Like if you had root 2 times root 5, you could say, oh, that's root 10. So what I'm going to do is I'm going to go ahead and just multiply this stuff together underneath the square root. So I've got negative 1 over 2 square root of, sorry, x times 1 is x minus x squared. So both of those are good answers. I think that this one that I boxed, I think that's the one you'd probably see on a multiple choice, but I'm not positive. Okay, and let's do one more with it getting a little bit crazier. Y equals secant inverse of e to the 2x. So again, I'm going to undo the secant inverse. So I'm going to have secant y equals e to the 2x. I'm going to go ahead and take the derivative of each side. So the derivative of secant is secant y tan y dy dx. The derivative of e to the 2x would be e to the 2x multiplied by 2. And so dy dx is 2e to the 2x divided by secant y tan y. Okay, so I've got my triangle to make. Y. So cos is adjacent over hypotenuse. That means that secant is hypotenuse over adjacent. So e to the 2x over 1. And again, this is that b side. And so I'm going to say 1 squared plus b squared equals e to the 2x squared. So 1 plus b squared equals, we got to multiply our exponents together, so that's e to the 4x. B squared is e to the 4x minus 1. So we got square root e to the 4x minus 1. Okay, so secant y, we already know, is e to the 2x. And then tan y is opposite over adjacent, so that's this side over this side. Okay, so we have dy dx equals 2e to the 2x over e to the 2x times the square root of e to the 4x minus 1. And we can simplify that a little bit. And so the derivative is 2 over the square root of e to the 4x minus 1.